Hello again, physicists. Today's video, we will be talking about amplitude as well as energy and kinematics as they relate to a simple harmonic oscillator. We will again be using the spring mass oscillator as our system of study. So I have recorded some video of a spring mass system undergoing oscillation. You will note that right now, the frame you are seeing in the video is representing the system before it has actually been put into oscillation. So the red dot is representing the equilibrium point of the oscillator. Remember that once I grab a hold of the mass and begin to pull on it, once I release it, the oscillator will oscillate around that equilibrium point. And it will always do that because there is a restoring force from the spring that continuously wants this system to go back to that equilibrium point. So at the very beginning, when I pull on the mass right here, okay, this establishes the maximum distance away from the equilibrium point at which my mass can travel. And that is what we call the amplitude. So there's the maximum displacement below the equilibrium point. And if I measure from there back to my equilibrium point, that represents the amplitude of this oscillator. If I go a little further after I let go, okay, when it goes above the equilibrium point and it gets to its maximum displacement, which is right about there, this is again representing the amplitude of the oscillator. So amplitude is just when the oscillator is at its maximum displacement from that equilibrium point. Next, we're going to talk about the type of energy that is present at various points in the oscillation, specifically the equilibrium point as well as at either of the amplitudes of the oscillator. So when I let go of the oscillator, okay, when it passes through the equilibrium point, remember this is the point where the spring is kind of naturally in a happy state. It hasn't been stretched or compressed any additional amount. Whereas at the amplitudes, like there or there, the spring is at its maximum compression or it's been stretched to its maximum amount. So at the points where we have the amplitude at a maximum, we're going to have a tremendous amount of spring potential energy that is present. And when the oscillator moves back to its equilibrium point, that spring potential energy that's stored up here will be converted into all kinetic energy, and it will have pure kinetic energy when it is at that equilibrium point of right about there as it passes through that equilibrium point. So if I kind of play this in real time, we start off with spring potential energy, kinetic energy, spring potential, kinetic. So you have this flip-flopping. So here spring potential, here kinetic. So we can take something away from that. Remember that kinetic energy is dependent upon the speed of the object. So if at the middle, at the equilibrium point, if my kinetic energy is present and at a maximum, that means that my maximum speed is also at the equilibrium point. In other words, the oscillator will be traveling fastest when it is passing through the equilibrium point. Now, at the amplitude, if we have the most amount of spring potential energy being stored, that means the spring has been compressed or stretched the most. And Hooke's law tells us that the amount of force acting on the mass depends on how far the spring has been stretched. So when the oscillator is at the amplitude, it is experiencing the maximum amount of force due to the spring. And consequently, because of Newton's second law, it'll also experience the maximum amount of acceleration. Another way to think about it is in terms of a change in velocity. When the oscillator gets to its maximum point, right before it gets to that amplitude, it's traveling in an upward direction, and then at the amplitude, it stops and reverses direction, and right afterwards goes in the opposite direction. When you have this direction change in velocity, that's usually evident of a significant acceleration at that point. Recapping, at the equilibrium point, you have kinetic energy at a maximum, and since kinetic energy depends on speed, the oscillator will be traveling the fastest at the equilibrium point. At either of the two amplitudes, you have a maximum presence of spring potential energy. And since the force exerted by the spring depends on how far away you are from that equilibrium point, the mass will be experiencing a maximum force and consequently a maximum acceleration. We will further investigate these concepts in class, so if you're a little bit over your head here, do not panic. Just make good notes, come to class with good questions, and until next time, physicists, until next time.